What are confidence intervals and how to interpret them? This video will focus on the 95% confidence interval for the mean difference when you're using a single mean and you're forced to use the t-curve. I'll describe what confidence intervals are and the different types that exist. I'll define important terms, and then I'll perform a specific example in which you are using one sample mean to estimate a mean difference using the t-curve. A confidence interval is an estimated range of plausible values for a population parameter. All confidence intervals can be constructed to have varying levels of precision or confidence. Commonly used levels of confidence are listed here. This video will focus on constructing 95% confidence levels. Different kinds of confidence intervals estimate different kinds of population parameters. One of the most common confidence intervals is one that estimates a population mean. Another very common confidence interval is a mean difference confidence interval, which tries to estimate the difference between two populations. This video is focusing on mean difference confidence intervals. As shown here, there are many different ways to compute a mean difference confidence interval, depending on the type of research situation you have. In the example that follows, I'll show you how to estimate the mean difference between two populations using one sample mean and one population mean when you do not know the population standard deviation. Before diving into some examples, it's important that you understand some key terms. A point estimate, as you will learn in the next few slides, is the most plausible value for a population parameter. And a margin of error is a range of values extending above and below the point estimate. And that margin of error is going to vary based on the sampling error in the study and the level of confidence or precision that you desire in your estimate. In both of the examples in this video, we're going to be using a sample mean to represent one population and a population mean to represent the other. And we're trying to estimate the difference between these two populations. And the point estimate is going to be the difference between the sample mean and the population mean. The margin of error is going to be computed using two terms. The CI value, which again is determined by the level of confidence or precision you want your estimate to have, and then the amount of sampling error that is expected in that study. By applying the margin of error to the point estimate, you'll get the upper bound and the lower bound of the confidence interval. Simply add the margin of error to the point estimate to get the upper bound, and then subtract the margin of error from the point estimate to get the lower bound. Remember, what you're trying to do is trying to find the range of plausible values for the mean difference between the populations. The upper bound value is the largest plausible mean difference, and the lower bound is the smallest plausible mean difference. The point estimate will always be exactly in the middle of the upper bound and lower bound values, and it is always considered the most plausible mean difference between the populations. In this example, we're going to use a 95% confidence interval to estimate the mean difference between two populations, specifically a married population and an unmarried population. We're going to take a sample of 61 married individuals, and we're going to find out that that sample texts their significant other on average 31 times per month, with a standard deviation of 11.72. On the other hand, the population of unmarried individuals texts their significant other on average 38 times per month. We have to use a t-curve here because we do not know the population standard deviation, or sigma. First, we compute the point estimate. The sample mean minus the population mean. 31 minus 38 gives us -7. This is the most plausible mean difference for the difference in text messages between these two populations. Next, we need the margin of error. The margin of error has two terms, the TCI and the expected sampling error in the study. The TCI I'll cover on the next slide. The sampling error, or the SEM, is computed by the sample standard deviation divided by the square root of n. So it's going to be 11.72 divided by the square root of 61, which is going to give us 1.5. Now in this example, we did not know the population standard deviation. That means we're forced to use a t-curve rather than a z-curve, and that means we have to use a TCI rather than a ZCI. The t-curve and the TCI changes value based on the sample size in a study. So in this case, the sample size is 61, which means we have a degrees of freedom of 60. And the TCI is going to be about 2. Now what this means is the TCI, a value between 2 and -2, those two values bracket the middle 95% of all possible t-scores. In order to find the TCI, you need to use a t-table, specifically a two-tailed t-table. You'll need to find the DF, in this case it's 60, and you'll need to use an alpha value of 0.05 because again, we're looking for a 95% confidence interval, and by using the alpha 0.05, you're identifying the two tails of the distribution, the areas that do not include the middle 95%, those will sum up to be 0.05. So that's why you need the 0.05 alpha level. So again, using the DF of 60 and the alpha 0.05, you'll find that the TCI is 2.0003, or essentially 2. Now that we have all of the components, we can compute our point estimate and our margin of error. Our point estimate again was -7, and our margin of error was about 3. Using the point estimate and the margin of error, we compute the upper bound to find it to be about -4, and we compute the lower bound to find it to be about -10. A figure will help you visualize what the upper bound, point estimate, and lower bound values really represent. The figure on the right is the distribution of all possible sample mean differences with a sample size of 61 or a DF of 60. The peak of the distribution is centered at -7, the point estimate. That will always be the case. And as you move away from the point estimate, the probability of that mean difference represented goes down. You can see that the upper bound value and the lower bound value have a much lower probability than does the point estimate. Specifically, the lower bound values and the upper bound values bracket the middle 95% of all possible mean differences. So it's not to say that the mean difference couldn't be outside of the lower bounds and the upper bounds. It's just that it's not very likely. We're 95% confident that the actual mean difference in the population is between -10 and -4. The most likely mean difference is the point estimate of 0.7. When interpreting confidence intervals, it's a good idea to identify where 0 is relative to the upper bound and lower bound. In this case, 0 is well outside of the confidence interval. Now, as we said previously, this doesn't mean that 0 is an impossible value. It's just highly improbable. In fact, based on this confidence interval, we would say that a 0 mean difference between these two populations is not plausible. In other words, it's not very likely. Based on the 95% confidence interval we just computed, we can be 95% confident that the married population sends between 4 fewer to 10 fewer text messages to their partner per month than the unmarried population. A 0 mean difference between these two populations is considered a not plausible mean difference because it is outside the range of the confidence interval. If you're interested in reading more about confidence intervals, this is an excellent resource. If you're interested in learning more about statistics, visit us at learnstats.com.